If you've ever actually tried to build a serious AI system, you know the feeling. It's kind of like you're trying to conduct this chaotic orchestra where none of the instruments speak the same language. Today, we're going to dive into a concept called CognOS. It's something that promises to be the conductor's baton, really proposing a huge shift in how we build, manage, and scale these incredibly complex systems.
Okay, let's just be honest and state the problem directly, because we have all been there. You've got these amazing models, super powerful tools, endless data streams, but actually getting them to work together in a reliable way, it just feels like a constant uphill battle. You're left wrestling with this total mess of frameworks, APIs, and data formats.
And what does all that chaos really lead to? Well, it leads to this. You end up spending weeks, maybe even months, writing what the source material perfectly calls fragile glue code. You know what I'm talking about? It's that brittle, custom scripting that's barely holding everything together. One tiny change over here completely breaks something way over there, and suddenly you're spending all your time being a plumber instead of creating real intelligence.
So that really brings us to the core question of this whole thing. What if we could stop being plumbers and actually start being architects? What if there's a way to work at a much higher level, focusing on what we want to build, not the nitty-gritty of how it all connects? Now, this idea isn't exactly new. In fact, if you look back, it's a pattern that shows up again and again throughout the entire history of software engineering. Every single major leap forward has come from this exact same principle, raising the level of abstraction. The journey here follows a really clear path. First, the operating system came along and freed us from having to manage hardware directly. Then, databases let us just declare what data we wanted, completely abstracting away the storage. More recently, Kubernetes abstracted away entire servers into these simple declarative manifests. So CognOS is proposing the next logical step, abstracting the very building blocks of cognition itself.
So how in the world does it actually do that? Well, CognOS is built on 3 core pillars that all work together kind of symbiotically to create this whole new layer of abstraction for AI. Let's break them down.
So the whole architecture rests on these 3 pillars. First up, you've got the event fabric. This basically acts as the system's perception. Think of it like System 1 thinking, those fast, automatic reflexes that just process raw data as it comes in. Next, there's the knowledge mesh, which is its trusted memory. This is what grounds all the reasoning in verified, structured facts. And finally, you have agentic orchestration. This is the System 2 deliberation, the slow, thoughtful, multi-step reasoning it uses to plan and take really complex actions. Together, they create a complete model for perception, memory, and action.
Okay, that all sounds great in theory, but what does it actually look like in practice? Let's walk through a couple of concrete, real-world examples that show the pretty dramatic difference this whole before and after approach makes.
So first up, we have a really common but incredibly difficult task for any intelligence team, creating deep research reports. Think market analysis, competitive intelligence, scientific summaries. It's a complex, multi-stage process for sure.
The contrast here is just stark. On the left, you've got the DIY nightmare, a whole web of custom scrapers, these fragile RAG pipelines, that's retrieval augmented generation, and reviews just scattered all over the place in Slack and email. On the right, with CognOS, you simply declare what you want. You just define your data sources, your knowledge structure, and the agent workflow, and you can even include built-in checkpoints for human review.
And here's the real payoff: a massive, massive productivity gain. What used to take months of painstaking, brittle engineering can now be configured declaratively in just a matter of hours. You get to spend your time refining strategy, not fixing pipes.
All right, let's look at another example. This time from the world of operations, real-time incident remediation. When a system goes down, speed and reliability are literally everything.
And again, just look at the difference. The old way means stitching together stream processors, writing a bunch of custom logic to detect anomalies, and running these brittle scripts that have zero safety checks. The CognOS approach is all about governance and automation. Events get correlated automatically. The remediation workflows have built-in human approval gates for risky actions, and the root cause analysis artifacts, they're generated for you automatically.
This quote really just hits the nail on the head. It's not just about being faster. It's about trust and reliability. An auditable, explainable system is one you can actually depend on when things go wrong. A brittle, error-prone system just adds more chaos to an already chaotic outage.
So, if the system is handling all of this complex orchestration, what's left for us humans to do? That's a critical question, right? And the answer is that our role actually becomes more strategic, not obsolete.
Our work just shifts upward. We become designers, defining the system's goals and rules in simple config files. We become operators, monitoring high-level system health instead of chasing down log files. And we become reviewers, providing that critical human judgment at key decision points that we've already defined by policy. We're guiding the system, not building every little piece of it from scratch.
So let's wrap this up by looking at the bigger picture here. It's really important to understand the magnitude of the change a system like CognOS represents.
We're not talking about making the old process a little bit faster or a little bit easier. This is a fundamental shift in how we approach building intelligent applications, period. This leap in abstraction is what finally allows us to move beyond these fragile one-off demos. It's how we start building robust, production-grade AI that is reliable, governable, and can operate safely at a massive scale.
And that leaves us with one final, really powerful question to think about. If all the time and all the energy you currently spend on that low-level plumbing was just suddenly freed up, what incredible new things would you be able to design, build, and create?